Week 21 of our SAT challenge question. Let's take a look at our question. We have a system of equations, as you can see there. In the given system of equations, a is a constant. The graph of the equations in the given system intersect at exactly one point, x comma y, in the xy plane. What is the value of x? And we got ourselves a parabola at the top line, and then, of course, the equation of a line. How did we do? Let's take a look. We did pretty good. It's about 71-ish%. Chose marigold, which is answer choice C, which is in fact the correct answer, and the other ones are just kind of almost evenly split there between A and B and D. And we rated this one our usual, right there in the middle, medium level question. Okay, so let's dive into the actual solution, and I'm going to give you a whole bunch of ways to solve it. What is the most efficient way to solve this? Well, since this is 100% calculator active, as is both of the SAT sections, math sections, I think that's actually the best play here. And we will, as we usually do, also look at it algebraically. So let's first call up Desmos, maybe side by side this so that I could easily type in and accurately type in these equations here. We've got y is equal to 2x squared minus 21 and 21x and then plus 64. And there you go. There's your parabola. And then we want to make a line that's going to intersect this guy, which is y is equal to 3, yeah, 3x. And then don't actually use your answer choices here as possibilities. And the reason why is because these answer choices over here are supposed to be the values of x. They're not the values of a. So I'm actually going to use a little slider. So plus, go over to the alphabet, put an a, add the slider, and then we're good to go. Okay, so I think that this should change. No, it does not change by integers, which would be handy. So I'm going to click on the 3.5 here, and under the step, let's go with 1. Is it possible that it's not an integer? I guess, but let's start with integers first, and then, if it isn't, then we can change it to maybe 0.1. Okay, so let me get a nice picture here going on. Move the screen so I can see the whole thing. And now, this looks like it intersects at one point, but it doesn't, because it would intersect way the heck over there too. So I need to move this thing down, 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 down until it hits at just one point, and it looks like we just found it. That point is called the point of tangency. Our line is actually a tangent line. It touches the parabola at exactly one point. And if I zoom out enough right here, I can just tap where the solution is, I think. Maybe if I hit the home button. I know that I can because I've done it before. Maybe I have to zoom way the heck. Oh, there it goes. Oh, finally. All right, so 6 comma 10 here. Let me pull this thing in. And we're pretty much done because it asks for the x value that makes the line hit the parabola at exactly one point, and the x value here is answer choice 6. Okay, so let's come back over here, and Desmos for the win. Desmos, that's solution number 1. Let me go back just a second here to Desmos, and notice that our a value is -8. This is interesting because answer choice A was -8. I would think that this would have been the most common wrong answer choice, but it wasn't, which is curious because if we go back over here, our next most, let's see, the most D, which is over here at +8. Interesting. Anyway, so how can we do this algebraically? Well, there's 2 ways to do it with algebra, and there's also one way to do it with calculus. If you know a little bit of calculus, I'll go ahead and show you. It'll be spoilers for those of you who take calculus eventually. Now, the thing that I would want to do if I'm solving a system of equations and I have myself a parabola and I have myself a line. I either solve it by graphing, which we just did, or I solve it by substitution. Substitution. In other words, I solve one of the equations for y, done, and then stick this equation, this expression in for y in the other one. So I would have something like 3x, oh, that's ugly, 3x plus a is equal to, that looks like a 9, or maybe a q, 2x squared minus 21x plus 64. There we go. Now, in order to solve any kind of quadratic, of course, we make the thing equal to 0. So we've got to get everything over to one side of the equation. So I'll have to subtract over the 3x's, which is going to combine with these negative 21x's to make negative 24, right? Let me just go ahead and write that down. Now, of course, I would not be doing this kind of thing. If I were doing this on my own, I'd just do it kind of in my head. And then I'd also want to subtract over the a. But there's nothing to, don't know what just happened there. There's nothing to combine the a up with, so I'll just put it right here at the end. So obviously everything's going to go away at the left. I'd have 0 is equal to 2x squared minus 24x's, and then plus 64 minus a. Now, besides factoring and graphing, there's also the quadratic formula that we could use to solve a quadratic equation. Are you familiar with the quadratic formula? I think so, because you probably have it memorized. Wait, how do you spell formula? Formula. Yeah. By Pop Goes the Weasel. It goes a little something like this. X is equal to negative b plus or minus a square root of b squared minus 4ac all over 2a. Anyway, so let me identify what the a, the b, and the c are. The a is the number that is right in front of the x squared. So a is equal to 2. Okay, and then we have our b is equal to negative 24. It's the number in front of x, so b is equal to negative 24. And then everything that's left, like the constant, is the c. And the constant's going to have the 64 minus a. It's that whole entire deal here. So c is equal to 64 minus a. Because a would be some sort of number. Whatever it is going to combine up with the 64. Like we already know that the a value is actually negative 8 from the previous one. So this whole thing would be the value of c. So now, I'm not going to put all of this into the quadratic formula to solve for x, especially since I have this little a. And just to be clear, this a up here for the coefficient of x squared is not the same thing as this a that's in the c value, okay? Anyway, what I'm going to do instead is focus on the part that's underneath the square root. The part that's underneath the square root is called the discriminant. Discriminant. And what it does is it tells us how many solutions we have depending on the value of what's underneath the square root here. Because if it's equal to 0, we would be adding or subtracting the square root of 0, which means we would have only one solution. So one solution happens when we have the discriminant, I'll just put as a capital letter D, is equal to 0. So that's what I'm going to force to happen with my A, B, and C right here. So from this, let's make our discriminant happen with, it is b squared, which is negative 24, squared, minus 4 times my A, which is times 2, times my C, 64 minus A. Okay, all of this is supposed to be equal to 0. And then I would solve this thing for A. So negative 24 squared, just keep in mind, just be careful here. This negative sign is going to go away when we square it. And I think that is 576. 576, I'll double check that in the calculator in a little bit. Multiply these two guys together, so minus 8, and then 64 minus A. equals 0. I'm going to do something a little bit unconventional, which is add this whole entire thing. Think of this as 8 times something. This is one complete package. I'm going to add that whole thing over to the other side. So 576 is equal to positive 864 minus a. Now, rather than distribute this 8 through the parentheses, I'm just going to divide it over to the other side. And so let's see, can you do that without a calculator? Probably. 24 and then square it. See, that's that 276. Is that what it had? Or 576? 576? I know it is. All right, and then divide that whole thing by 8, and I get a nice even 72. So 72 is equal to 64 minus a, and then subtract the 64 over. That's going to give me 8 is equal to negative a is equal to negative 8. And of course, that's what we got on Desmos. Come back over here to Desmos real quick. And you can see that a value right here, this is in box number 3 here, was equal to negative 8. So we were able to find that thing algebraically. But again, that's not the answer. Now what you have to do is, well, you know what? We probably didn't even have to do that since we didn't need to know what the value of a is. It's understanding this. If this thing has one solution, your square root is gone, it's 0. So the only thing that we would need to do is take negative b over 2 times the a value, and I would have my x. So my x would be equal to negative 24 over 2 times my a value, which is 2. Look at all this. I did all of this extra work for absolutely nothing. However, sometimes the question might ask for the a value. Seems like a thing that it might, like if they were going to use this kind of question again, how they could change it up a little bit. Anyway, so negative makes that positive 24 over 4, which is equal to 6. Well, look at that. We got our 6 value. And if we had recognized this before, where this whole discriminant was equal to 0, it would have saved a whole bunch of time without a graphing calculator. Okay, there's another way to do it too. Let me go ahead and show you the completing the square. And we've seen completing the square in a couple of these other videos as a technique to solve quadratic equations. I need to steal this guy real quick here. So let's duplicate this and then bring this guy down. Now, completing the square, what you usually want to do when you have a quadratic equation is you isolate the squared term and the linear term, the ones that I have in the box there, and then you get the other two, the other stuff on the other side. Now, this is ordinarily just some sort of number, some constant value, and you'd either add it or subtract it to the other side of the equation. So I'm going to separate those things. I'm going to keep the 2x squared minus 24x on one side, and now whenever I go to subtract this stuff to the other side, the 64 is going to be negative, but the a is going to be positive when I add the a over to the other side. So a minus 64. And yeah, I switched the sides because that's just what I do. Okay, now notice that almost everything is even. The only thing that's not is possibly this a value, but I'm going to go ahead and divide everything by 2, which is going to make my numbers a little bit smaller. Easier to do the complete the square thingy on. So divide by 2. X squared minus 12x is equal to a half a, and then minus 32. Okay, and then I go ahead and complete the square. Now to complete the square, you only complete it on the variable terms, the x squared and the minus 12x. The other stuff, I'm just going to scooch it over to the side here, and then I'm going to add a little blank here, which is going to help me complete the square. And whatever I add to the left-hand side, I've just changed the equation. So I have to balance it back out by adding something else on the right-hand side. How do I find that number? The technique is taking half of the middle term. So this is negative 6 when we take half of it. And now you square that negative 6 and you get a positive 36. So I'm going to add 36 to both sides of this equation. Okay, so now that I've gotten that under my belt, and again, if you needed to understand how this actually works, you go check out one of those other videos linked in the description. Not really. Anyway, so now the left-hand side, the way that it factors as x minus 6, it's basically this term, this number that we get after we take half of the middle term, and then square that guy, is equal to, and then the right-hand side of this equation is going to simplify as a half a, and then what's that, plus 4. Okay, so far so good. Now, the only way that I'm going to get a single solution from this, because that's what we want, is if this whole thing on the right hand side was equal to 0. Let me demonstrate that for you real quick. Let's say, for example, x squared, or x minus 6 quantity squared, was equal to 25. Well, one of the techniques, instead of like expanding this thing out, is just take the square root of both sides. So when I take the square root of the left-hand side, I get x minus 6. When I take the square root of 25, I would get 5. But there's another square root of 25, and it's negative 5, because negative 5 squared is still 25. So usually what we do is we put a little plus and minus in front of it. It's the same kind of thing that happens with the quadratic formula right up here, plus and the minus. Okay, and then if I add the 6 over, x is equal to 6 plus or minus 5. There's two solutions here. One is 6 plus 5, which is 11, or the other one is 6 minus 5 is 1. I would make this quantity equal to 25 if x is equal to either 11 or 1. So 11 minus 6 is 5, 5 squared is 25. 1 minus 6 is negative 5. Negative 5 squared is also 25. So what I'm showing you here is that the only way that you can get a single solution from this is, instead of this being a 25, it's got to be equal to 0. So if I come back down here, I go x minus 6 squared is equal to 0. Take the square root, I have x minus 6 is equal to just 0, because the square root is 0 is 0. And then add the 6 over, and you are done. Now, not only that, if you wanted to, if you had to find the value of a, you can get that from this too, because, excuse me, as we just mentioned, 1/2 a plus 4 should be equal to 0. Subtract over the 4. Multiply by 2, a is equal to negative 8. Again, the thing that we got with Desmos. Okay, now, if you are in the, let's say, 11th grade and you're taking the SAT, you can use some secret calculus techniques on this. And again, this is assuming that you know a little bit of calculus here. And you'll pick up a little bit of calculus along the way. We've had some previews of it in geometry. You'll have some previews of it in your next two classes, Algebra 2 and Pre-Calculus as well. So it's all based around slope. So if I come back to my little picture here of my graph, I'm going to go back up to this point here on box number 4, and I'm going to turn this point on so I can see a little dot right there. And I'm going to zoom in on this point. And when I do, see this tangent line, the blue thing? When I do, it's going to eventually become indistinguishable from the graph of my parabola. And what we talk about in calculus is how the tangent line to a curve represents, if you really, really zoom in, the slope of the graph at that point. It turns into something that looks linear. And here, let me snap this picture real quick. And then bring this back over here into Notability so I can draw on this thing. And if I were going to just measure the slope using rise over run, starting from the point of tangency right here, and then just coming straight up, and then coming over here, I have a 3 over 1, so my slope is equal to 3. Notice that, of course, is the slope of our linear equation right here, right? Of course, our slope is equal to 3. So basically what's happening is detailed in the question. If you're having only one point of intersection, then that means that this guy must be a tangent line. Now, In calculus, to find the slope of a tangent line, what we do is we find what's called the derivative. And it would look like this. There is a shortcut method, which is called a power rule, to find the derivative. And what you should understand about derivative is that it just is the same thing as finding a slope function. On lines, you only have one slope. On something like a parabola, you have a different slope at every single point, and the derivative tells us what each one of those slopes is. So if I take my parabola equation, which was y is equal to 2x squared minus 21x plus 64, that's the original one, and I take its derivative. Here's the secret technique to take the derivative using the power rule. Y prime is what we call the derivative. I'm going to highlight this. This is the same thing as that. Yep. Are you going to be tested on this? No. But this is some secret techniques. You should not tell your family about this. Anyway, so the power rule goes like this. You take this exponent of 2, you leapfrog it down to meet this other 2, and they're going to multiply. So 2 times 2 is 4x. And then as far as this linear term goes, think of this as an equation of a line. Its slope would be negative 21. You can also use this, secret power rule, which goes like this. That is an understood exponent of 1 times this negative 21, which would make that a negative 21. Go back to blue. All right, so this details the slope at every single point on that parabola, this little equation here. If we put in, let's say, 0. At 0, 4 times 0 is 0, minus 21, you get a negative 21. The slope at x equals 0 is negative 21. That's super steep. Anyway, we want to force this slope into being equal to 3. Why 3? Because that was the slope of the linear equation. Y is equal to 3x plus a. So if I set this thing equal to 3, 4x minus 21 is equal to 3. Add the 24 over, 4x is equal to 24, divide by 4, x is equal to 6. Look at that. That was probably the fastest thing to do, but that also assumes that you've gone through, at least a semester's worth of calculus. Anyway, that should probably do it for this question.